Hello ladies and gentlemen, welcome back. This video tutorial is for students who are in Geometry Goal 4. We're finally getting into the basics of trig, which is one of the coolest parts of geometry that you can do. Before we actually get into the topics, I want to talk about this particular title. It's pronounced SOH-CAH-TOA, and what it is it's your lifeline. Like if you learn nothing else in this chapter, you want to know your SOH-CAH-TOA. What happens is SOH-CAH-TOA. They each are basically a series of abbreviations, and it basically tells you your proportions. There's that word from earlier, your proportions for your trig functions. So, sine, everyone reads it as sin, but you actually pronounce it as sine, is going to be your opposite over hypotenuse. Cosine is going to be your adjacent over your hypotenuse, and tangent is always going to be your opposite over your adjacent, okay? Literally, this is your lifeblood right there in a nutshell. You're going to want this in your notes. The question the next ask is, what does this actually mean? So let's make ourselves a right triangle here, because shocking, right triangles are going to be a big thing in this particular section. Let's have this angle, and I'm going to use one of my fancy Greek letters and call it theta. All right, if I look all the way over, this is going to be my opposite, okay? If I look next door, that's going to be my adjacent, and hypotenuse is always hypotenuse. Okay, says Ms. Dubois, well, what if we take it in a different way? Let's now move our precious little Greek letter theta and put it over there. Now, what's our opposite, adjacent, and hypotenuse? Well, let's look. Let's see here. Trace our way down. That's going to be our opposite. And then look right next door. That's going to be our adjacent, and hypotenuse is going to hypotenuse. That's what you're going to be constantly doing in this thing, is always orienting your triangles, and I have a couple of topics that sort of train you in this. I'm literally not going to say anything for a few seconds, so you can hit pause and get this in your notes. Again, get this in your notes. Okay, welcome back. Now, so sine, cosine, tangent ratios. Here's where they start getting you used to all of this. So you want to find cosine A, sine A, and tangent A. First things first, where is A? There it is. Okay, so the first thing they want is cosine. Cosine is adjacent over hypotenuse. Adjacent is, adjacent is 12. 12 over 13. Sine A, sine is opposite over hypotenuse. Opposite is, you're going to put across, 5 over 13. 13. Tangent is opposite over adjacent. So opposite, which is 5, adjacent, which is 12. That's what they're doing. So this is a good way to sort of train yourself in getting used to your SOH-CAH-TOA. Next up, we want cosine of m, tangent of m, and sine. Everyone reads it as sin. That's wrong. This is sine of m. So cosine, let's look up here. Cosine is adjacent and hypotenuse. Where's m? Where's m? So what's our adjacent? 9 over 41. Next up, tangent. Let's see here. Tangent is opposite over adjacent, so it's going to be 40 over 9. Okay, next up, let's see here. Sine is going to be opposite over hypotenuse, which is going to be 40 over 41. And that's it. That's your SOH-CAH-TOA in a nutshell. Let's see here. And let's get a couple others down. So now we have SOH-CAH-TOA. This is something that you tend to write in your notes page after page after page until you have it memorized, just because it is a very useful way to remember which is which. So let's see here. There's our x, so we want sine x, tangent x, and cosine x. So sine is opposite over hypotenuse, opposite, which is f, over hypotenuse, which is e. Tangent is opposite over adjacent, so opposite over adjacent, which is d. Cosine is adjacent over hypotenuse. Adjacent is D over E. Again, they're just getting you used to the proportions. All right? So we want to find tan x, sine x, and cosine x. So tangent is opposite over adjacent. Opposite, which is F, over adjacent, which is E. Sine x is opposite over hypotenuse. Opposite, F, over hypotenuse, D. Cosine is adjacent over hypotenuse. Adjacent, which is E, over hypotenuse, which is D. And that's all you're doing. And then the next thing that they're going to do is they are going to have you actually do it out on a calculator. This is actually really cool, and this is where you guys living in the modern era is kind of a thing. Oops. Because back, even before my day, I at least had the calculators the same way you guys did. But my teacher, to make myself old, my teacher had to have a textbook full of trig tables. Like, it was nuts. But here, all you have to do is 21, and then you want to find the tangent of it. 0.3838, and then you're rounding to the nearest hundred. So 0.38, and then it's going to be 49, and we're going to find the sine of it, which is 0.75, 0.75, and now we want cosine of 81. So 81 cosine is going to be 0.15, no, 6 makes it round up, so 0.16. Let's do it again. So what is this? Cosine 67. 67 cosine is going to be 0.39, 0.39, and then we have 59 tangent, 59, 9 Miss Dubois. Tangent is going to be 1.66, 1.66, and then sine 39, 39 sine is going to be 0.63 because the 9 makes it round, so 0.63. So 3 topics back to back to back, getting you used to your trig functions. And now let's justify why those trig functions actually work. So JK over KL, and notice how it says round to the nearest hundred, so we're going to be using our calculator again, huzzah. So JK over KL, KL, so that's tangent, right? That's opposite over, yeah, that's opposite over hypotenuse. So that's going to be 17.616. Yeah, let's try that again. So it's going to be 17.16 over 9.45. Ooh, that's going to be a mess. Okay, so it'll be 17.16 divided by 9.45, and that's going to be, oh look, 1.81. So 1.81. And I'm going to give you an educated guess. What do you think tan 61 over 2 is going to be? It's going to be 1.81. Funny that. Let's see here. Let's do PQ over RQR. Okay, so that's going to be 1.81. And then let me guess. XY, yep. And then ZY is this. So it's going to be 1.81. Okay, the reason... You'd obviously do the calculator to figure these out, but the reason why I knew this was tangent, because again, SOH-CAH-TOA. When I looked at these proportions, there's my angle, that's my opposite, that's my adjacent. Opposite and adjacent, this was going to be my tangent, and that's what you're doing for this topic. Same thing over here, so let's see here, AB over AC, AC, and then there's my angle. So that is, this is adjacent, and that's the hypotenuse. Adjacent and hypotenuse, I know that this is going to be cosine. And I'll leave you guys to figure out the actual calculations and computations on the calculator, but it's pretty straightforward. So that is the basics of SOH-CAH-TOA, and then we're going to, now that we're comfortable with using all of your basic trig functions, now we get to use them in actual math problems. It'll be a thing of beauty. As always, stay happy, stay healthy, stay safe. I will see you in the next one.